only pays you interest on the money you've actually put in the account. So you're not earning any interest on the actual balance in the account. You're only earning interest on the actual deposits that you've made into the account. With compound interest, you earn interest on the money that you put into the account and any interest that you were paid previously. So if I put $20 in the account and I earn $5 interest, with simple interest, I would only still be paid interest on that initial $20. With compound interest, I'm going to get paid interest on that $25 that's in there. Okay. Compounding is the calculation. So if you have annual compounding, the interest is calculated once a year. Semi-annual is twice a year. It's every 6 months. Quarterly is 4 times a year or every 3 months. Daily is either 365 or 366 if it's a leap year times a year. This is one of the most common for savings account is daily compounding, but it's paid monthly. You could potentially also have weekly, monthly, bi-weekly, and semi-monthly. And bi-weekly and semi-monthly get confused. Bi-weekly is every other week. So you have 52 weeks in a year, so you have 26 bi-weekly periods. So you divide the 52 by 2. Semi-monthly is twice a month, usually on set dates, like the 1st and the 15th. And there's 2 for every month, so you have 24 of those periods. So bi-weekly is 26 times a year, semi-monthly is 24 times a year. Those aren't very common for paying interest, but it can happen. Anything can happen. It's up to the bank, to decide when that they're going to calculate interest. Okay, so let's say you have a savings account and you earn daily compound interest. They don't put that in the account every day because typically that's less than $1 a day that you're earning in interest. It's pennies most often. And so rather than give you a 2-cent deposit here and a 40-cent deposit there or whatever, they just calculate it all month long, and then on the last day of the month they'll deposit it, they'll credit it to your account. So it'll be, rather than a bunch of little deposits, just one larger deposit. So usually if you're talking about annual compounding, it gets credited the same time. If it's semi-annual compounding, it probably gets credited the same time. But if it's things that are less than that, they might choose to credit it annually or credit it monthly. If it's weekly or daily, they'll credit it at a larger time frame. Okay, so let's look at if you have $1,000 at 6% compounded annually. Now we're going to use, for section 4, we're still using simple interest formula because we don't have compound interest formula yet. So we have $1,000 in 1 year, so our time is T is 1. Our rate is 0.06, and our P, so that's P and this is R. So interest is equal to PRT. So we have 1,000 times 0.06 times 1. So in that year, we're going to earn $60 in interest. We want to know what the new balance is, and so our balance is our initial 1,000 plus the $60 we earned, so $1,060 at the end of the year. Okay, so that's if it compounds annually in 1 year. Now, Maria is going to deposit into an account that pays the same amount of interest, and she's going to deposit the same amount of money, but instead of compounding annually, it's going to compound semi-annually. So this is 6 months. Okay, so T is going to be 0.5 because it's 6 months of the year, half the year. And then R is still going to be 0.06. And so we have to calculate this twice. We have to do the first 6 months And then we have to do the second 6 months. I won't write that just yet. Okay, in the first 6 months, she has her $1,000 times her 0.06 times 0.5, because it's only 6 months. And that gives us $30 in interest. So her balance after the first 6 months is going to be 1,000 plus 30, so 1,030. Now, during her second 6 months, she's going to earn interest on the interest that she earned the first 6 months. So the second 6 months, same formula, but instead of 1,000, blue. Instead of 1,000, we have 1,030. Same interest rate, same length of time. The only thing that changed was that she now has earned $30 in interest. 30,000. That would be funny. When I calculate that, it's now 30.90 instead of 30. So her balance at the end of the year write properly, is 1060.90. I know it doesn't seem like a lot, but just calculating one extra time and paying interest on the interest earned an extra $1 in that year. Nothing was different. Put the same $1,000 into an account paying the same amount of interest, but earned an extra $1 just because they did one extra calculation. 0.5 is for the 6 months for the year, 6 over 12. Good. That one extra calculation halfway through the year earns you an extra $1. So, you know, compound interest earns you more money. Three months would be quarterly. Okay, so this would be happening 4 times a year instead of twice a year, the compounding. But let's find out how much it actually earns at the 3-month mark first. Okay, so 3 months, that's 3 over 12. So that is 0.25 years. Okay, so I'm going to take the same $1,000 at the same rate, but for only 3 months, and I'm going to earn $15, and so my balance at the 3-month mark would be $10.15. Okay. Well, let's kind of extend this and say, how much will we have at the end of the year? Well, we're going to have 3 more compoundings because it's quarterly. So that we're going to do this 3 more times. So this was our first 3 months. So if we do our second, we're going to start with, yeah, the more you compound, the more money you earn. Yeah, so because we start, instead of being 1,000 this time, we're 1015 this time. So if I take the 1015 times 0.06 times 0.25, instead of $15, it's $15.23. Okay, so then our balance is going to be $10.30.23. Now, if I go backwards, we're at 6 months right now because we had a 3-month and a 3-month. At 6 months here, we had $10.30. At 6 months here, we have $10.30.23. It's not a huge difference because it's a small amount of money. $1,000 is a small amount of money in banking world to earn interest on, but it's 23 cents. Same length of time, same amount of money, same interest rate, one extra calculation, and we've already got 23 more cents. so for our third compounding, we're going to start with 10, 30, 23 instead of 10, 30. And we're going to earn 1545. And so our balance is going to be 1045, 68. And so in our last compounding for that year, we'll have 1045, 68 times, that should be down here, 0.06 and 0.25. Yeah, sorry, I ran out of space. And we earn 1569. Not right now. Okay, so at the end of a year, if we used one compounding, one time, we end up with 1060. If we compounded twice, we had 1060.90. If we compounded 4 times, we end up with 1061.37. The only thing difference between these different accounts, same amount of money, same interest rate, it's just the number of calculations done per year, and it's making a $1.37 difference. And again, sure, that's not a huge amount of money, but it all adds up. And so for every $1,000 you had in this account, you'd earn an extra $1.37. And then for every year, it would earn more and more and more and more and more. So the compound interest, you earn more quickly. Okay, and if it's daily, we're not going to do all 365, don't worry. For one day is equal to 1 over 365 years. Okay? So we are going to do this way. We have 1,000 times our rate times 1 over 365, but we're going to convert this. We're going to do 1,000 times our rate times 1, in case there was a different number there, over 365. So that's 60 divided by 365. And so 16 cents for that one day. So in the end of the one day, our balance would be 10.16. And then the next day, the interest would be calculated not on 1,000, but on 1,016 cents. And then the next day, let's say it earns 17 cents that day, because that will, then the next day it would be calculated on 1,032 cents. And then the next day it would be counted on 1,049 cents, or, and so it would just keep building every day. So probably several days in a row, you'd earn the same 16 cents, 16 cents, 16 cents, and then something would bump it up to 17. And then you'd earn 17 for a few days, and then something would bump it up to 18. Because you don't get paid fractional pennies, right? Nobody gives you like 2/3 of a penny, so they round it. But at the end of a year, hold on, whoa. If you do the whole year, instead of $1,061.37, you'd have $1,061.83. Again, that doesn't seem like a huge amount of difference, but if you have several $1,000s in the account, and if you're talking year after year after year, it's going to grow that much faster. But this is with the same amount of money and the same interest rate, and that changes that much. Any questions so far? So we're going to make a table, basically. So we'll start with the date. And the opening balance. And then we're going to have any deposits or withdrawals. Yes, bless you. The new balance. Then the interest. And then the ending balance. Okay, and the reason I'm making a table, excuse me, you don't need a table to do this problem, but on your homework packet there's a table, so I want you to be familiar with it. Okay, so we start on July 11th. And on July 11th, she had a balance of $1234.98, and she withdrew $200 for car repair. And she received a $34 check, which she deposited. Okay, so that's July 11th. On July 12th, she deposited a paycheck of $345.77. Okay, we want to know what is her ending balance on July 12th. We're looking for this information right here. Okay, we have a daily compounding at 3.2%. And so the first thing we need to do is we need to find this new balance here. So I'm going to do $1234.98 minus 200 plus 34. That's my first calculation. I'm going to go ahead and maybe label these as A, B, C, D, E, and F. So this is A. So minus 200 plus 34 gives us 1068.98. That goes right here. Now for B, we have to calculate the interest on that 1068.98. It's at 0.032 because it's 3.2%. Excuse me, and it's 1 day. So I'm going to multiply 1068.98 by 0.032, and then I'm going to divide by 365. So 1068.98 times 0.032 divided by 365 gives me 0.09. That's her interest that she's earning, 0.09. And then so for C, I add the interest that she earned to the amount of money that was in her account. And she now has 1069.07 at the end of the day on the 11th. Well, if that's what she had at the end of the day on the 11th, that's what she has at the beginning of the day on the 12th. And then she gets a paycheck which she deposits. So for D, we need to add in that paycheck. So I add the 349.77, sorry, 345. She has 1414.84. And then for E, I need to calculate the interest on that. So same process, but with a different amount. So I'm multiplying 1414.84 times 0.032, and then I'm going to divide that by 365. And on this day, she's earning 12 cents. So for my final answer, I'm going to take that 12 cents that she earned and add it to the 1414.84. gives us our final balance on July 12th. Now, when the bank is calculating your interest, if they do daily compounding, this is how they'll do it. They'll calculate it every day, but you won't see all this. You won't see the 9 cents and the 12 cents. Your balance that you would see would be like this balance here, and then plus 345.77 until the very end of the month, and then they'll take this interest column and add it all up and then deposit it. Okay, so the compound interest formula, which is at the bottom here, is the formula that calculates all of your compound interest on a single deposit over some length of time. So that example we were doing just a minute ago where we did the quarterly and we had to do 4 different calculations to figure out a year's worth of interest. With this formula, we do 1 calculation to figure out a year's worth of interest. The annual percentage rate is the percentage rate that's used to calculate interest. The annual percentage yield is the actual amount of interest, or like the actual percent that's earned. This is usually a little higher than the APR. And this is what banks will advertise. So if they pay 0.5%, but the yield is 0.6%, they'll advertise 0.6% because it looks better. And then people think that that's the percent that's using for the calculations, but it's not. So you want to we'll talk about how to calculate the yield also. Okay, so for the compound interest formula, P is the principal. Okay, so that's the deposit. R is the interest rate as a percentage, and it's, or not as a percentage, I'm sorry, as a decimal. And it's the APR, not the APY. N, you have 2 of them, is the number of times compounded per year. So if it's once a year, you've got a 1. If it's semi-annually, it's 2. If it's quarterly, it's 4. If it's monthly, it's 12, etc. And then T is the number of years. T always has to be in years. So if it's over a couple of months, it could be part of a year or 1.5 years or something like that. So, but T always has to be in years. So first, what I recommend, just, you know, when you're starting these, always write the formula out first. It'll just help you get familiar. Okay, we have $16.50 is what she's depositing, so that's our principal. Our interest rate is 0.03. Our time is 3 years, and we're compounding daily, so our N is 365. Oh, that's kind of hard to see, isn't it? Let me change that to a different green. So we're going to plug those in, and this is where that order of operations review we did comes in. Do you guys remember that in the algebra packet? Anybody? Okay. Order of operations, PEMDAS, parentheses, exponents, multiplication, division, and then addition and subtraction. So parentheses comes first, which we have to do what's inside the parentheses first, which we have to do division before we do addition inside the parentheses. So what I do is I do, let me highlight. I do this part and this part sort of simultaneously because they don't interact with each other. I have a division and a multiplication, but they're separate. So I usually do those first. So this gives me 1650 times 1 plus, and then 0.03 divided by 365 is 0.0000829192, etc. And then 365 times 3 is 1095. And now, calculators, hold on. It's not very good. The TIs are much better. Okay, so let's pick back up. We've got the the 1 plus, so we're still in the parentheses, so we have to do this addition next. Okay, so addition inside the parenthesis came next. And then exponent is next. The biggest mistake I see people make on these problems is after they do this addition, they get this part right, but then they multiply and then do the exponent. You have to exponent before you multiply. So we have to take the, I'm just going to come over here now. The 1.000082192 to the power of 1095, and that gives me 1650 times 1.0941705. And then I multiply that times 1650, and I have 1805.38. Oh, yeah, I didn't do that. I'm sorry. If we come back to this screen, I just realized I never told you. This B is for balance in the account, not interest earned. So this 1805 is not how much interest this money earned. That's the balance in the account after the interest has been added in. So in the account at the end of this 3 years, so they put 1650 in the account. They don't touch it for 3 years. They now have 1805.38. Okay. Page example thing, whatever this is. We're going to try to find the annual percentage yield. So before we can find the annual percentage yield, we have to find out how much interest was actually earned. So we have to calculate the interest first using the same formula. So we put 8,000 in at 3.2% compounded daily for 1 year. Okay. So I'm going to take and do this division and this multiplication, which is very simple. I can do that one in my head. And so I have 1 plus 0.000087671 to the 365. Add those together, and then raise it to my power first. So I have to the power of 365, which gives me 1.032516057. And when I multiply that by 8,000, I get 8260.13. So So this is her balance. So first step is to find the balance. The second step is to find the interest. And that's the balance minus the deposit. So 8,260.13 minus 8,000. So it's a minus, not a times. 260.13. Now to find the yield. The formula for yield is to take the interest earned, the actual dollar amount earned, and divide it by the principal. So I'm going to take the 260.13 that she earned and divide it by 8,000. Bless you. And so that's 0.0325. And I convert that into a percentage. 3.25%. So she was paid 3.2%, but she earned 3.25%. So can you see why the banks would advertise that as opposed to the 3.2? Yes, no? Okay, well I can see why the banks would advertise that. It looks better.